Hello my dear friends, welcome to my YouTube channel ANIRUDH'S Chemistry World. This is class 11th JEE NEET and CBSE Class Chapter 2, that is some basic concepts of chemistry. Okay, this some basic concepts of chemistry chapter is also called as mole concept. Okay, did you understand this? Some people say it's some basic concepts of chemistry and others say as mole concept. Okay, we usually in competitive exams prefer the word mole concept. Okay, basically now I am going to give introduction of this chapter. Okay, I am going to give the introduction of this chapter. See, from the past times, scientists use the scientific methods to discover something, right? And suppose there is one atom. To make calculations and measurements, they use the scientific methods and did lots of calculation and gave many laws. Okay, and based on them, they calculated the amount of substance, the number of moles, and the terms which are going to be we are using in this chapter. Okay, they use molarity, normality. These words you have been come to if you have already know about this chapter. Okay, scientists previously did research upon these calculations and upon the atom and the molecules. They did calculations in very microscopic level. Okay, they did microscopic level and estimated this. Okay, now we are going in this chapter some basic concepts of chemistry. This comes under, since it is dealing with calculations, always the subject of chemistry which deals with calculations is called as physical chemistry. So this chapter is also coming under the category of physical chemistry. Okay, this is a part of physical chemistry. Okay, now the matter which we are seeing around is mainly classified into two types. That is pure and impure. Okay, the matter which we are seeing around is mainly classified into two types. First one is pure and another is impure. In pure, we have again some classification. This is I am writing about the chemical matter, chemical classification. Based on chemical classification, I will be writing about physical classification here. But in chemistry, we will focus mainly on the chemical classification itself. So this is chemical classification. Okay, I will be writing here for your better clarity. This is chemical classification. Okay. Chemical classification. Okay. Matter is divided into two types: pure and impure. This pure matter is of two types. First one is elemental, that is element, another is compound. Okay, the pure substances which you are observing is of two types, that is element. You will be seeing the pure form of element, right? Nitrogen, oxygen, some metals if you take iron, aluminium, these are the metals which will come under pure elements. Okay? Now elements are again divided into three types. These elements are divided into three types. Based in the periodic table, you might have been observed if you have ever seen it. Okay, if you don't know about periodic table, we will learn it later. I am going to explain it very clearly. Don't need to worry. These elements are classified into three types. Okay, first one is metals. From your childhood, you have been seeing that metals, non-metals. You might know in your lower classes. You might be studying. Again, I will be telling. These elements are of three types. First one is metals, second one is non-metals, third one is metalloids. Metals, non-metals, metalloids. You might be knowing metals and non-metals, but it might be the first time you are knowing about the metalloids. Okay, let us see. First one is what I call metals. Second one is non-metals. Again, third one is metalloids. Okay, metalloids. Okay, in these metals, I'll be giving the examples. See, aluminum. Okay, iron, sodium, potassium, etc. Calcium. These are all metals. Okay, and in non-metals, see, all these metals are either S block elements or B block elements, and some of the B block elements. Okay, non-metals are, you might be knowing this: oxygen, nitrogen, chlorine, fluorine, bromine. Right, these are all non-metals. Okay. Now metalloids. In metalloids, you'll be having. See, you might heard that about this silicon and germanium semiconductors. These semiconductors are nothing but these semiconductor elements which they use is metalloids. And metalloids, in this metalloids we have examples: germanium, which is represented by GE. Okay, G small e, GE, and silicon Si. These are the metalloids. You mostly use the metalloids. These are important. You need to remember them. Okay. See, for board level it's important. For competitive exams you better see it, because they can pick the question like this, right? Okay. See, in compound, in compounds you will be having covalent compounds. In compounds, and another one is ionic compounds. You might have heard the compounds are of, in your 10th class, you might heard that compounds are of two types: covalent and ionic. Okay, in covalent compounds, you will be having like AgCl, AgBr. These are covalent compounds. Whereas ionic compounds, in ionic compounds, what is ionic compound? The compound which is formed when the electron is transferred from metal to a non-metal. The electron is transferred from metal to a non-metal, then it is called as ionic compound. You might have heard in your 10th grade. Okay, in ionic compounds you will be having NaCl, KCl, and AgBr also. See, the AgBr. What is AgBr? This AgBr is silver bromide. Silver bromide comes under both covalent and ionic compounds. Okay, but mostly, in most of the cases, you will be seeing in covalent. Okay, let it be. You remember one thing, right? No, you just make a note like this. You just see it. I'll write this. First, I will complete this. Okay. In impure, you will be having mixtures. Okay. In these mixtures, again two types. In impure, what is impure? Impure is the basic which is not pure. In mixtures, you will be having homogeneous. Okay, nobody is genius. The mixture name is homogeneous. Okay, it's easy to remember. Mixture first name is homogeneous mixture, and second one is heterogeneous mixture. Okay, the two types of mixtures are homogeneous mixture and heterogeneous mixture. Okay, in homogeneous mixture is a mixture which has uniform composition throughout. I will be writing the definition, don't worry, just the basic classification. In homogeneous mixture, you will be having, example is sugar solution. Uniform, see, homo, what is homo? Homo means same. So homogeneous means the solution which has uniform composition. If you see the sugar solution, its uniform composition will be there. Where you will be nowhere, if you mix, if you stir properly, you will nowhere be seeing the crystals of sugar. It will be mixed well. Okay, it's a uniform composition. It will be having. Okay, And in heterogeneous, hetero means different. Heterogeneous mixture you will be having, example, sand water. Okay, in sand water also you will be seeing the same thing. Where suppose I have sand and water in my hand, okay, like this, and in water, if I pour some sand, it will settle at the bottom and it will not mix at all. If you try to many times also, okay, you just note it down. And in physical classification, the matter is classified into, I'll write about here. The matter is classified into 3 types. What are they? See, the matter which you see around upon physical classification, okay, is what? Means physically means which you will be able to see. Matter, chemical classification, you are unable to see with your eye. Okay, this matter in physical classification is of 3 types. You will be seeing day-to-day life. That is, first one is solids, second one is liquids, then gas. Solid, liquid, gas. That's only solid, liquid, and gas. You just note on this. Yeah, okay. I'll write the examples also. Solid. In solid, you will be having like iron, which is solid. Calcium is solid. Okay, these are solid at room temperature. Liquid. In liquid, you will be having the example of the bromine. Liquid bromine. There is only one non-metal which is liquid. That is bromine Br2. It's very important. You just note down. Bromine. Okay. And water is also liquid. Okay. In gases, you will be having ammonia NH3, gas O2, okay, oxygen which you breathe, and carbon dioxide which we exhale. Okay, oxygen which we inhale and CO2 which we exhale. Okay, you just note it down. One thing you need to pay attention here, that is, see, in some books which I have seen, AgBr, that is silver bromide, is both acting as covalent as well as ionic, but as per the NCERT, I saw different books where the AgBr comes under both covalent and ionic, and in NCERT also it is mentioned both it is covalent and ionic, but in examples they gave only it is as ionic. Okay, we'll go with them. Okay, then in covalent compounds we'll take another example, that is this your organic compound, most wanted the element, that is glucose, that is C6H12. Okay, one thing, did you understand? In covalent compounds you have organic compound, that is glucose C6H12O6, and also you can take other example, sucrose, that is the formula of sucrose is C12H22O11. C12H22O11. Okay, just take this down. We'll go to the next thing, next explanation. It's just a basic idea what is going behind. This is chemical classification, that is physical classification. In pure elements, in chemical classification, pure and impure will be there. In pure, you will be having 2 types, that is element and compound. In element, okay, you will be having 3 types, metals, non-metals, metalloids. In compound, you will be having covalent and ionic. These are just glimpses or summary. In impure, you will be having mixtures. Okay, in mixtures are of 2 types, homogeneous and heterogeneous. I will explain in brief, don't need to worry. Okay, copy it down. or take a screenshot. Yeah. Okay. Done. Next we'll go to see, one thing you need to understand is the whole physical chemistry is based upon your skill, your solving skill. How much you build your solving skills, or how much good you are at mathematics, that much good you will be at physical chemistry. It's not about only calculation, it's all about your logical thinking and applying the formulas, like linking 2-3 formulas and deriving your own formula, like that. In your first chapter you have been seeing, right? You have been seeing, right? E is equals to hc nu. Okay, this is one formula I gave you, and C is equals to lambda nu. If you want to express energy and if you want to derive the relationship between energy and wavelength, how will you do? You need to link up these two formulas. It's all about your skill. Okay, in terms of nu, if you right, it's nu is equals to C by lambda. This is equation 1. This is equation 2. If you say this is equation 3, okay, we'll go by line. Otherwise, it won't look good. Okay, 1, 2, and 3. Put like this. Means I am just training you how you need to think in the whole chapter. Put put 3 in 1. If you get E is equals to hc by lambda. This is one equation you will be getting. Similarly, lambda is equals to h by p is there, and if you and lambda is equals to h by under root 2m ke. We have already seen that lambda is equals to, that is de Broglie wavelength is equals to h by under root 2m ke. And suppose if you forget this formula, let's say you only know that lambda is equals to h by p, you can derive the momentum p is equals to what? mv. Right? Kinetic energy is what? Half mv square. This is the solving strategy I am telling you. It's a very, 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 very important role it will be playing in when you are solving. Kinetic energy is equals to half mv square. Okay? You can write this as half mv into v, right? v into v. This mv you put here. What it will be? Half p into v. If you multiply and divide with m, what happens? This is the magic. M into v is again p. So into p. Okay, mv is nothing but momentum again by m. Okay, it's p square by 2m. I know, and I already directly know that kinetic energy is equals to p square by 2m. This is the derivation. This is the process you need to apply. Okay, half mv square. You need to get the idea that half mv square can be written as mv into v. In this mv you can substitute p. This is a fast process you need to run in your mind, and this it will take time. It will develop very slowly. It's not like if you learn today you will get tomorrow. You need to practice it, right? This is a glimpse, or this is a solving strategy which I am giving from your first chapter. I am just recalling these formulas. You can take like that also. Now, see the element. What is element? In element, what is element? Element is the purest form of matter. The matter which I have seen previously in physical or chemical classification, that is the matter word, keyword we are using here. What is element? Element is the purest form of matter. Okay, element is the purest form of matter. It's a very pure form. Suppose, examples in element. In elements you will be having pure elements. Like if you form, example oxygen, it's a pure oxygen. Suppose let us take simply chlorine, it's also pure. Carbon, it's also pure. Okay, sodium, it is also pure. Like this, the pure elements you will be finding. But in these elements, you will be finding only some only in the pure form. Means naturally available in the nature. Okay, but this oxygen and chlorine cannot be obtained as nascent oxygen O and normal chlorine Cl. But I am telling you, means element, it is the purest form of matter. Means it is not mixed with any other element. Element is the purest form of matter, which is, means in that element you will be having only all the elements, all the atoms of the same element. Suppose this is the element which we suppose this is the beaker. Okay, in this beaker I have let us say, okay, I have not beaker, otherwise it will go to compounds. Okay, you just see this diamond, you know diamond, right? Diamond, it's a three-dimensional figure, but it's not possible to draw the three-dimensional figure. So let us say this is diamond. Okay, don't worry about this diagram. This is a diamond, and this diamond is the purest form of carbon. Okay, diamond is nothing but it will have only all the atoms of the carbon. Suppose this is the diamond, which is the purest form of element. In this diamond, you will be having all the atoms of carbon only. You will not be having any other atom of other element. You will be having only of carbon. Okay, see, this is three-dimensional figure. You also note it down. It will be helpful in your P block elements chapter. Diamond, this is three-dimensional figure. Okay. Now, you didn't understand about element. Next, let us go to compound. Let us go to compound. This compound, it is, okay, in compounds you will be having two types. Pure compound, impure compound. In compounds you will be having two types, that is pure and impure compounds. In the pure compound, you will be having the two or more atoms will be combined, two or more atoms of the same element will be combined. Where impure compounds, where you will be having different atoms of the different elements. Suppose, let us say in pure elements, in pure compounds, you will be having, example, suppose if we take the compound of pure element, that is O2. In oxygen, the bond will be like this, right? The bond between O, that is here only the oxygen atoms only combined in the fixed ratio to form oxygen. No other element is involved. That's the meaning. Okay. O2, N2, Cl2, Br2, and whatever, all the pure elements. And you'll be finding one element rarely, the carbon also. It's not a compound. Okay. No, it's an element. S8. You might heard this. S8. Sulfur. It's a purest form of compound. And in impure compounds are the compounds which are formed by two or more elements. When two or more atoms of the different elements combine in some ratio, they form impure compounds like CO2, carbon dioxide, NH3, ammonia, H2O, water. This C6H12O6, this is also impure, because see, this is because in this, if you see, you will be having three elements. First one is carbon, second one is hydrogen, third one is oxygen. Means it's not a uniform composition of the same element. In this, suppose you have in beaker, you have some C6H12O6. H12O6. In this, you will be having atoms of carbon and atoms of hydrogen and atoms of oxygen also in this ratio. 6:12:6, which is 1:2:1. Okay. You see, if you want to calculate the ratio of the element, suppose in this, if you take C6H12O6, if you want to calculate the ratio of carbon is to hydrogen is to oxygen, what is there? How many times carbon is taken? 6 times. Hydrogen is 12 times. Oxygen is 6 times. C6H12O6. If you cancel with 6 tables, 6 1 are 6, 6 2 are 1, 6 1 are 6. 1 is to 1 is to 1 is the ratio of 6 6 H12 6. Okay. And this is the thing. You just wrote it down. It's a basic information again. No need to worry. We are going step by step. Hopefully I'm explaining better, because these are the things which form the basic concepts of chemistry. The chapter itself is basic concepts of chemistry. You need to learn from the scratch. Okay. You just note it down. Take a screenshot of this. Yeah. Now, you see, I just written just now, because to save your time, if I write and explain, it's going to take more time, and I don't want to waste your time even 1 second. Okay, so just see. Now, we have seen the elements, different elements, and their elements and the compounds and their definitions. Okay, now let us see the symbols, the reason behind the symbols of the elements. Some elements have different symbol, which is completely different from their name. Like if you see sodium, right? Sodium, its spelling is SODIUM. Okay, sodium, but its symbol is Na. See what happens here. Element. Suppose if you take the elements, normal general elements, and their symbols. Okay, elements and symbols. Here in the element, first element we are taking is carbon. Okay, carbon has symbol C. Generally, in the periodic table, the symbols are given such that either the first alphabet is taken from the English name of the element, or the first alphabet is taken from the Latin name. They say first alphabet, but sometimes in Latin name you will be having different name, right? So, so the symbol is also different. Okay, basically the symbols which are derived from the symbols which are derived for the elements are basically either from Latin word or English word. Okay. So in the element carbon, you will be having symbol C. Its first alphabet is C, so it's C. In chlorine, you will be having first element as C only. Second element is L, since we have chlorine. L is there. Okay. In chlorine, the symbol is Cl. Hydrogen, first element of the periodic table is hydrogen. First alphabet is its symbol. Hydrogen, H. Potassium. Okay, the atomic number of potassium is 90. You might be having known. Okay, you might have known this. And the atomic number of the potassium is 90. And the potassium has the symbol of K. You might ask me, why is this like that? Why it is only K, not P? If you ask like that, see, in potassium, okay, in potassium the symbol is K, because the Latin name of the potassium is kalium. Latin name of the potassium is what? Kalium. In this kalium, the first letter is what? Observe carefully. In kalium, the first letter is K, so symbol is given as K. That's the logic. In sodium, similarly, the symbol is Na, but since the Latin name is natrium, it's taken from this Na. This Na, right? See, it's resembling. Okay, this is the logic. Okay, we did not go in depth from where it is derived. I am just telling from where it is derived actually. Now mixtures. Since in the introduction I told you about the mixtures are of two types. In the impure, in matter is divided into impure, and in impure we have mixtures. We have two mixtures: heterogeneous mixture, here is homogeneous mixture. Since similarly, what the same which I have written here is mixtures. This mixture's first mixture is homogeneous mixture. What it is? Homogeneous mixture. What is homogeneous mixture? The mixture which has uniform composition throughout. Okay, if you observe the sugar solution, what is sugar solution? Adding sugar to the water and mixing, stirring it well. Okay, where you will never notice even a single crystal of sugar. It will be uniformly spread out. Okay. Now in this homogeneous mixture, the best example is sugar solution. Okay. If you mix the sugar in this water, you'll be seeing very clearly. It will be like water only. You will not able to differentiate between them. Okay. There's no difference. If you even take like this in your hand, it will be having uniform composition. Okay, that's what the meaning is. In anywhere we go in chemistry, one logic is homo. In English or chemistry, whatever means the subject, homo means same. Do you remember like that? Hetero means different. Just remember like that. Okay. It's a trick, personal tricks. It's Anirudh trick. Okay. Nobody gives. It's Anirudh's trick. Okay. Note it down like that. Homo means what? Homo means same. In English, you might heard this homophones. Means right. Homo means the same. Similarly, this homogeneous. Homo means same. Hetero means different. Okay, you note it down. This also homogeneous mixture. Now you might have understood this. Okay, homogeneous mixture is a mixture which have uniform composition throughout. The mixture has uniform composition throughout the mixture. I told you the example previously. Sugar solution. What is sugar solution? Sugar plus when added to water. This is sugar solution. Okay. Now heterogeneous mixture. Hetero means different. So different mixture. Heterogeneous mixture is a mixture having non-uniform composition. Is a mixture which have non-uniform composition, or which where the uniform is where the mixture is not uniform. Okay, mixture having non-uniform composition is called as heterogeneous mixture. In the example, best example is sand plus water. That is sand water. If you add sand to the water, what happens? All the sand particles will be settling down, and if you even stir, and it will come up for some time, and again it will go down and settle at the bottom of the vessel. Okay, so the example of heterogeneous mixture is sand plus water. This is the best example. Okay, if we leave the chemistry for this time, I am telling you. Actually, if I tell this as per chemistry, it's wrong. But for your understanding, I am saying. Did you ever see the precipitate? Yeah, you might have seen this precipitate, that is AgBr or AgCl. You might have observed this. You see this AgCl and AgBr. In your 10th grade, you may in the 10th grade, the chemical first chapter, chemical reactions, you might be learned this. Precipitates, about precipitates. In double decomposition reactions, you will be seeing the formation of a precipitate which will be settling at the down, right? That is, this says precipitate is symbolized with like this down arrow bar. Okay, like this. Okay, this big representation I gave for your understanding. Now AgCl and AgBr, that is silver chloride and silver bromide, are precipitates. Okay, these two precipitates, what happens is, when you add silver to chlorine or silver to bromine, what happens is, it will, you will be, directly you cannot obtain this. In the double decomposition reaction you will be seeing. Okay, if you want the correct reaction also I will give. See, ACl plus AgNO3 gives AgCl plus KNO3. Okay, this is the reaction which you have seen previously. On other reactions you will be seeing. There were n number of reactions. Let us say KCl plus AgNO3. Okay, KCl plus AgNO3 gives AgCl, double decomposition. This will decompose this will take this, and this will take this. AgCl plus KNO3. Where AgCl is a white precipitate, you might have learned this. AgCl. You might have known this, okay? AGCL. This AGCL, what happens is, it will settle at the bottom of the solution. If you mix a KCl and AgNO3 in the beaker, this AgCl will be settling at the bottom. Even if you still, it will not mix. This is the thing similar to this of heterogeneous mixture. This is a very best example. As per chemistry, I cannot say precipitate is heterogeneous mixture. No, it's not at all valid. But for your understanding, to imagine the precipitate, if you understand, you will be understanding about heterogeneous mixture. Similar, this sand water also is a similar example. It's a best example. It's not an example. It's your understanding. For your understanding. Okay. This AgCl will be settling at the bottom when you do this reaction. Okay. This is the type of heterogeneous mixture which I have observed when I have studied and took this example. Okay. Okay. Now, this is very important. Very important. Where you will be having more number of JEE, NEET and ncert questions. See, mostly in competitive exams you won't be, without this there is no calculation at all. Somewhere or other question you will be seeing, at least if you solve some 5 questions, some 3 questions it will be involved with this. Especially in physics you will be seeing more, and chemistry also not less, you will be seeing more. Okay, you just see this. Mostly used prefixes in chemistry, okay? Or in physics also. Mostly used prefixes. These prefixes are nothing but 10 to the power of something. 10 to the power of some number where we will be having some names, specific names. So mostly used prefixes are these. Now, very important, because in question, in anywhere you will not be seeing this. In question, you will not be given this. You will not be given this, and you will stuck up there. And so I saw most of my friends who did this mistake. They didn't know this prefixes and faced the problem. Even though they know the calculation, they confused between pico. What is pico and nano? They confused. Question went wrong. Instead of +4, you will be getting -1. Okay, it's very big mistake people do. Okay, you just learn this. You need to revise and write on your in front of your table and revise them daily. You will be getting in 2-3 days. That's it. See, 10 to the power of -15. 10 to the power of -15 is femto. 10 to the power of -12. Okay, is pico. This is very important. See, personally, I too got the question in this JEE mains and my state board, state level competitive exams, which is ncert. This 10 to the power of -12 is very important value. 10 to the power of -12, very important value, because people won't remember this. Generally we will know the micro, nano we will be using regularly. We won't use this regularly. Suddenly you will be given the question that 1 picometer. What you will do? You need to understand. You need to study. Okay. 10 to the power of -15 is femto. 10 to the power of -12 is pico. It's represented by pi. Okay. 10 to the power of -12 is pico, represented by pi. Very important. 10 to the power of -9 is nano. Right? You might be seeing this wavelength given in nanometer. 10 to the power of -9 nano. 10 to the power of -6 micro, represented by mu. 10 to the power of -3 is milli. 10 to the power of -2 is centi. You will be knowing this already. 10 to the power of 3 is kilo. 10 to the power of 6 is mega. These are also very important. Similar to that of pico. More than pico, I can say giga is very important. Gigabyte. You will say you will calculate the MB. You will calculate the data in 1 gigabyte. What is 1 gigabyte? It's 10 to the power of 9 byte. Okay. 1 gigabyte is 10 to the power of 9 byte. So 10 to the power of 9 means giga. 10 to the power of 6 is mega. 10 to the power of 9 is giga. 10 to the power of 6 is mega. 10 to the power of 9 is giga. Very important. Note this. You just note down this. I'll give you 10 seconds. You just take a screenshot, please. And don't forget to subscribe my channel. this is an encouragement for me, and also I'll be making more videos and tricks for you. So kindly subscribe my channel. So that it will be very helpful to the students like you. Okay, and also you will be benefited because I personally have some tricks. I'll where no teacher will give, so because they don't have time, but as I have time, I'll be sharing with you and make time. I'll create time for you and do it. Okay, take a screenshot. You just see this now. See, we just entered into the real concept. From here, you need to focus more. Till now, we just see the things which we need to understand, the keywords to be understood for doing questions. Okay. Now, you will be seeing this important things. Okay. Let us start. International system of units. What does this international system of units mean? Okay, this international system of units means SI unit. This SI units full form is international system of units. Okay, in this you will be having 7 fundamental physical quantities or 7 base quantities. Okay, in SI units, to express SI units, you will be having some physical quantity, right? For suppose meter is there. For meter, what is the physical quantity? Physical unit is this meter. For that, what is the physical quantity? The physical quantity for meter is length. Similarly, for this SI units, you will be having some physical quantities. Okay, there are 7 base units. Okay, if there are 7 base units, there are 7 fundamental physical quantities. There are physical quantities length, which is in physics you might be having this length, mass and time dimensions. That is, length dimension is L, mass dimension is capital M, and time dimension also time capital T. Length is also capital L. Okay. In this physical quantity, you have 7 physical quantities, fundamental physical quantities. For these 7 fundamental or base physical quantities, you will be having 7 units, SI units. Okay. For the first physical quantity is length. For length, you will be having unit as meter. See, its representation is M. Mass, its unit is what? Kilogram, represented by kg. Time, its SI unit is seconds, that is represented by S. And temperature, okay, temperature, you will be having SI unit as Kelvin. Always you will be seeing in thermometer also, not this thermometer, in chemical labs. Okay, in chemical labs you will be having thermometers. There you will not be seeing in Fahrenheit or Celsius. You will be seeing in Kelvin only. So the temperature is always expressed in unit of Kelvin, and this Kelvin is symbolized as K. Now, 5th physical quantity, which you will be studying in current electricity. You will be dealing with that circuits and all. That is current electricity chapter in your 12th grade. So for this, at this stage, understand it. Electric current. Oh yeah, I remember one thing. In your 10th grade, you might be having this electricity chapter. Okay, there you have learned this electric current. The electric current represented by I has SI unit ampere. Ampere or ampere. Okay, unit is A. And the amount of substance. This is a new thing. In the first chapter also, I used the term mole. Here's that is. Okay. 6th physical quantity. This is not correct. You can write in any order. I am writing like this. Okay. As per the book. 6th one is amount of substance. Okay. This amount of substance is a physical quantity where you will be having the unit moles. The moles are symbolized with the letter small n. The moles are represented by letter small n. You just remember this. I highlight it. Okay. The moles unit is symbolized by n. Amount of substance is nothing but moles. Suppose I have one glass of water. How much you will be measuring? It's a very macroscopic level, microscopic level also. So if you have some Okay, in class for chemistry, in okay, in test tube, suppose you have like this. In this you have some chemical. Okay, you will be measuring in terms of moles. Means amount of substance. How much amount is there? You will be measuring in terms of moles. Represented by N. And this we won't use. It's not important. Not much also. It's not important at all. Okay, it's not important. You will be having nowhere questions. But you need to understand this. If you in board exam, if you asked to write all 7 base units or fundamental units, you should be able to write. So that's why I'm telling. 7th physical quantity is luminous intensity. What it is? Luminous. You might have observed this tube light. Okay, other stabilizers. Luminous company, like luminous. Okay. Similarly, luminous intensity. What it is? Luminous intensity. This luminous intensity represented by IV. What it is? I. Okay, I is there, right? I to the subscript V. This luminous intensity is represented by IV. The unit of luminous intensity is candela, represented by CD. Okay. Please note it down. Take a screenshot. I'll give you 5 seconds. Okay. Now let us go to scientific notation. Everywhere, if you go in any question or in board exams, you will ask always to express in scientific notation. If we don't ask to write in scientific notation also, you need to express. Sometimes what happens is, if you get a question of 4 marks and if you write even though answer is correct, you will get only 3 or 3.5 for max. 3 or let us say 3. You will be losing 1 mark because you didn't express that quantity in this scientific notation. This scientific notation plays a key role till your completion of your 12th. Okay. What is this? Scientific notation. Okay. Scientific notation is represented is what? A into 10 to the power of B. The scientific notation is represented as it expressed as A into 10 to the power of B. This A into 10 to the power of B is called as scientific notation. Okay, A into 10 to the power of B is called scientific notation, where this A is called as base. Where A is called as what? Base, and B is called as, okay, in general you can say B is power or degree. B is power or degree, but in terms of scientific notation, if you say, you need to call it as order of magnitude. Okay, in scientific notation, what is A into 10 to the power of B? It's a scientific notation form. Okay, and where A is the base, B is the order of magnitude. What it is? Order of magnitude. Okay, order of magnitude. B is called as order of magnitude. In this order of magnitude, you need to understand one. This one catch. In this order of magnitude, that is B, you will be having some questions where we will not mention as 10 to the power. If you have, suppose for example, say let us say 10 to the power of 5. Suppose in question he want to express you, he want to tell you that in question it is 10 to the power of 5, but he will not directly give. Sometimes if we want to make it complex question, he won't give as 10 to the power of 5. Instead he will tell the order of magnitude is 5 or magnitude is 5. You need to understand. There is no way. So, if order of magnitude is given or magnitude is given, you need to express like this. If you have 10 to the power of 5, okay, some quantity is say 3 into 10 to the power of 5. And mostly he will not ask like this much complex. So this is enough. If you have 10 to the power of 5, he might say the order of magnitude is 5 for this quantity. If the order of magnitude is 5 for this quantity, means the quantity is 10 to the power of 5 directly. You should understand. That's the thing. Okay, let us do this example for your understanding. Example: express 391.5 meter into scientific notation. Okay, express this quantity into scientific notation. What is the scientific notation? A into 10 to the power of B. One thing. We missed one point. Here A, this base, right? Here A value should always lie between 0 to 9. 9.99 means the A value, I'll write here, okay, let us write here, the A value must lie between 0 to 10. In mathematics, in sets, you might have been learning, you might have learned this less than, strictly less than. What does this mean? A strictly less than 10. Okay, A strictly less than 10 means A must be less than 10. It should not be equal. Means A shouldn't be equal to 10. If it is equal, then what's the use? You can directly write 10 to the power of something, right? So A should be strictly less than 10. That is the rule of the scientific notation. Scientific notation, A should be lying between 0 to 10. Okay, express this into scientific notation means in 391.5 you need to express as 3.915. Okay, 1 391.5. 3.915 you need to write like this. How many places it went left side? 1, 2. Right? 1, 2. So you need to express as 10 to the power of 2. You can write like this. Okay. So this is 3.915 into 10 to the power of 2. Where base is, that is A, is equals to here. If you compare with this with 8 into 10 to the power of 3, A is 3.915, B is 2. Okay, B is 2. You need to understand this. Okay, take a screenshot. Okay, we completed this first part of the video. The next part of the video we'll resume. Okay, we'll see. Just revise the notes till now what I gave, and also the examples, tricks, whatever I gave. You just revise it, go through the notes. Okay, and then start from here. Okay.